Okay, today we're going to do Unit 1, Lesson 2, or Lesson 1-2. The scientific process. This video will be on YouTube. I typically will post things 10 minutes after the period is over. So for any of you who are ever absent, on a regular Monday, the video should be posted shortly after 11:30. But on Tuesday through Friday, it should be posted a little after noon, after 12 o'clock in the afternoon. That's when I'll have them online. So if you're at home, you're sick, you need to make sure that you don't fall behind. Mondays around 11:30, Tuesday through Friday, a little bit after 12 o'clock in the afternoon. All right, here we go. First couple terms we need to familiarize y'all with is going to be quantitative and qualitative. Quantitative is all about numbers, quantity. If I was asked by the office, what is your quantity in fourth period honors chemistry? I would say 33. That's an actual number. You hear quantity in there. So it's going to be numbers and measurements. In my AP biology classes, my students will be taking the AP biology exam in May, and half of their exam is FRQs. Some of you may know what that is. Those are called free response questions. Some kids think that the more you write, the better it looks. And I try to tell them it's not quantity, which is amount, it's quality, which is the degree of the work. I have seen students write 500 words of crap, and I've seen students write 100 words of pure gold. So it's quality in that sense, not quantity. On the other hand, quality or qualitative is going to be information. Things like color. My shirt is orange. That's a qualitative measurement. Odor. Shape. Things like that. Descriptions, but no numbers. Numbers is quantity. Your next term I'd like to discuss is hypothesis, something you've likely heard since you were in elementary school, but I'm going to give you guys hopefully a better understanding of this word. There's a word that is thrown around in our regular talk, our regular communication, our regular vocabulary that is misused, and that term is theory. There was a video recently, I don't know if you guys ever heard of it. You may have seen it on your social media where there's a woman saying, I'm telling you right now, that blah, blah is not real. Y'all see that? Now, some of you might, I have a theory as what was wrong with her. That is an improper use of the word. A theory is not what you are meaning to say. We misuse it all the time, so don't feel too bad. The term that you are hoping or intended to use is hypothesis. I have a hypothesis as what was going on in that situation, not theory. A hypothesis is a tentative explanation. Maybe I was going to meet up with some friends this afternoon. I say, let's meet up at tentatively 5 o'clock. That means it's not set in stone. It's what you're shooting for. It's your best approximation. A tentative explanation for what has been observed. Let's say out of nowhere, Dane sneezes. Well, why did he just do that? I have a hypothesis. His nose was a little irritated and he sneezed. Maybe Nick is over there coughing. It's like, well, what's my hypothesis? His throat is scratchy, or maybe he has a cold. So a hypothesis is a tentative explanation of something that's been observed. But so you guys know, a theory which we improperly use a lot is supported by evidence. So if I say, I have a theory as what was wrong with that person on that airplane, you have no evidence. You're just kind of spitballing based on what you see. Spitballing is where you're trying to make a best assumption. A theory is supported by evidence. It is formed as an attempt to explain things. And here's the most important part. I'm going to write it in all caps. That have been substantiated by data. If you see someone doing something, or let's say that you're walking your dog and you cross paths with someone who has a tripod dog, their dog is missing a leg. You might, oh, I have a theory as what happened to that dog's leg. No, you don't have a theory. You have a hypothesis as to what happened to that dog's leg. Maybe the dog had cancer. Maybe the dog was shot in the leg. Maybe the dog broke its leg and they couldn't heal it. There's a lot of different hypotheses, but a theory is based on evidence, on data that you don't have yet. So if you see someone on a plane acting up, you know nothing about that. You're just trying to come to a conclusion on what you see. That's a hypothesis. I know that we don't use that word a lot, but I hope that you learned that when you say the word theory, or you hear people use the word theory, it's being used inappropriately in that sense, okay? Next, we have experiments. An experiment is meant to test whether your hypothesis is correct or incorrect. If I were to see Kellen on an airplane doing that exact same behavior, and I'm going to say, Kellen, I think you might have put something in your body you shouldn't have, you know what I mean, for you to act like that on an airplane. That's my hypothesis. Maybe he's on drugs. We can put that to the test. I can take a blood sample. I can take a urine sample. Do all these different analysis. Experiments are where you're putting your hypothesis to the test. An experiment is controlled observations that test the hypothesis. Girls, if you are putting on a new shade of makeup and you put some on one side of your face and you don't do anything to the other side of your face, that is an experiment. You think this, let's say that some makeup might cover up that pimple that's been really annoying you. You can test it and see if it actually works by applying it, see if it does the job. That's an experiment. Sometimes you might get results you didn't expect. That's why we test things. When automakers make cars, do you know how many vehicles, completely built vehicles, are wrecked during auto safety inspections? They put cars at 50 miles an hour into a wall, 60 miles an hour into a wall, 70 miles an hour into a wall, fully built cars that cost tens of thousands of dollars because they want to observe what happens when this vehicle is in an accident at this rate of speed. And what happens to the dummies inside and the airbags and all that stuff. Those are experiments. You're testing in a controlled situation what your hypothesis might work. So let's say that engineers say, if this Audi was in a head-on collision at 60 miles an hour, the driver should survive. All right, let's put it to the test. Put a dummy in there. Dummy has all these sensors like facial impact, chest impact, and you're ramming into a wall. And the dummy sends all the data to your computer and it says, well, according to this data, the person would have mild bruises and contusions, and that would be it. They would survive. Okay, great. So it's all about controlling a scenario to determine if your hypothesis is accurate or not. In an experiment, you have independent variables. Still with me back there, Aiden? I'm going to teach this to you like how it was taught to me. Aiden, what letter does independent begin with? I control it. I control this part of the experiment. This is a variable that you plan to change. But the way that it was taught to me, I control it. Aiden, I'd like you to come up here for a moment. You're going to be our test subject, okay? Come on up. Let me see if I can get the camera to work here. Hey, everybody, this is you wave your fans.
It's good.
All right. I want you to stand on that stool.
Stand on
Yeah.
it?
Are you afraid?
Kind of. I don't want to fall over.
It's not gonna. I can stand on it. I'm a little bigger than you. Go on. There you go. Okay, now face your adoring audience. I want you to hold this Stegosaurus. It's my favorite dinosaur. Be careful with that. I want you to hold this platypus.
You
All right.
Kind of draw my pencil.
Sure, I'll hold it. Now we're going to conduct an experiment. I want to know how long it takes for you to drop those two toys from about your chest height. I'd say it's probably about 9 or 10 feet from where you are. I want to see which one. No, I want to see how long it takes for them to hit the ground. Okay.
Tell me when to drop it.
3.
But wait, both at the same time?
When I say 1, okay.
All right.
3, 2, 1. Now, what part of this experiment did he control? Did he control the speed that they fell, or did he control the height from which you dropped them? That's the independent variable. Now, before you come down, I got another question for you.
Yeah.
Do you play any sports?
Yeah, football.
Football, okay. What position you play?
Quarterback.
Quarterback, all right. I want to know if you can complete a pass.
I mean,
What part of the experiment can you control?
who I throw it to?
What can you not control?
Who catches it?
So which one of those is the independent variable?
Where I throw it to?
Bingo. You got it?
Yeah.
I control. You need help or can
No, I got it. Thank you, though.
There
You
you
want
go.
me to pick this up?
I got you. Okay, so let's turn this off. So independent begins with I control. If you are going to try to find out how tall, follow me, I'll do this. How tall sunflowers can grow if you expose them to sunlight for 8 hours a day for 1 week. I'll say all that again. You want to see how tall sunflowers will grow if you expose them to 8 hours of sunlight a day for 1 week. What do you control? How much sunlight they get. What do you not control? How tall they grow. I think you've got it. So that gets me to the dependent variable. This is a variable that changes as a result to a change in the independent variable. Aiden, what is going to affect a wide receiver's ability to catch the ball? Can you give me a few factors?
How the ball's thrown.
How the ball is thrown. What else? Okay, weather. What else? Things that you can control. You can control where the ball goes. What else can you control?
How fast the ball.
That's what I was looking for. The velocity. Those are his independent variables. If I'm the quarterback, I control how far I throw it. I control the aiming. I control the velocity, the speed. Velocity is a physics term. It means speed. What he cannot control is if the wide receiver catches it with 2 hands, or if the right 1 hand, or doesn't catch it at all. Those are things he can't control. But the route that the receiver takes, how if he catches it over his head, or maybe right in his chest, or off the ground, those are things that the receiver has to adjust to based on where Aiden throws it. The dependent variable is dependent on the independent variable. That's why it's called a dependent. Why didn't anybody tell me I spelled it wrong? You guys are making me look silly on YouTube. There we go. The dependent variable depends on the independent variable. I want you to realize something. My first year teaching, it took my students 2 weeks to figure that out. What does the dependent variable depend on? Exactly. It's called a dependent variable for a reason. It depends on the independent. What does independent begin with? I control it. I control where I'm dropping the toys. I control how much light the flowers get. I control how far and how hard and where I throw the ball. I don't control how long it takes the toys to hit the ground. I don't control how much growth the sunflowers get. I don't control if my wide receiver catches the ball. Those are all dependent variables. And then we have a control group. This is a standard of comparison. This doesn't change. So girls, I was talking about makeup with you. Let me actually put this to the test. Nah, you don't have to draw it. I just want you to see it. Okay, girls, let's say this is one of your faces and you want to see this new makeup looks good on your cheeks. You want to conduct an experiment. Don't laugh. I really don't know how makeup works. There we go. You use the makeup on a cheek. You leave the other cheek alone. Which one of these cheeks is the control group? The cheek with makeup or the cheek without? This is your control. So what do you call the cheek with the makeup?
Independent.
No, independent is what you control. That's a part of, no. You're on the right track. Bingo. This is the experiment. You manipulate the experimental group. You don't do anything to the control group. I have another example for you. Here's your garage door. Your garage door is white. You want to paint it blue. You want to see if this new shade of paint that you just bought from the paint store is going to look good. So you paint this part of the door. What would you call the part of the door that you actually did color blue, which is what you're hoping to turn it into? That's the experiment. What do you call the part of the garage that you didn't even touch? Why do you have a control in the first place? To compare. C word, to compare. You want to compare it. Now, think about medicine. Check this out. I have 2 patients, and after this, we'll move on. What time is this class over today? We got really short classes. 11:46. We got 5 minutes. Okay. This patient has cancer. This patient has cancer. It's the same cancer. I have created a miracle drug for this specific cancer. I need to know if it works. So I have a pill and a pill. These pills, I don't know the difference by looking at them. It's not like a red pill and a blue pill. They're identical. One of them is the real thing. The other is what we call a placebo. It's a fake. It might as well be a Tic Tac. It's nothing. And I'm going to do a blind study. This means I don't even know who gets what. So I'm just going to randomly give this pill to this patient. And I'm going to give this pill to this patient. And I'm going to observe the results in a laboratory setting for days and weeks, maybe months. Let's say about 3 weeks later, patient number 1 begins to show improvement. Patient number 2 has nothing. Who could you potentially conclude who received the actual drug? 1 or 2? Yeah, you do that based on your results. So who is the experimental group here? 1 or 2? 1. So what would you call 2? The control group. Now, there might be cases where I give a random person the miracle drug and there's no change between either of them. So that tells me the drug didn't work. So I need to go back to the lab and maybe create something better. But the purpose of a control group is to compare your changed results. If you don't put makeup on one side of your face, that's your control group. If you don't paint one side of your garage door, that's the control group. The key word is comparison. You want something to compare. Okay, let's move on to the last part. Whoa. Conclusion. This is a judgment based on the information obtained. I want to conduct an experiment that if Garrett eats nothing but donuts for breakfast, lunch, and dinner for a month, that he'll lose weight. I can do that. I can observe my results for a month. I can weigh him at the end of every day and see if he's lost weight compared to when he started. Let's go flash forward into September. We've been doing this for a month. He's gained 20 pounds. Okay. My conclusion is eating donuts for breakfast, lunch, and dinner will not lead to weight loss. It will actually lead to weight gain. That's your conclusion. Now, you might not be happy about it, but the facts are the facts. You know, nowadays we have to argue what a fact is, and it's really sad. If the results aren't what you hope for them to be, you know, sometimes too bad. A conclusion is a judgment based on the information obtained. And the last thing I want to get with you guys is the benefits of chemistry. And then we're going to actually get into some numbers. I need you guys to bring calculators for tomorrow. If you don't already have them with you, I need your calculators tomorrow to be able to add, subtract, multiply, and divide. Chemists are an important part of the team of scientists that solve many problems and issues we have today. And I could probably do this for an hour, talk about all the stuff that chemists do. I'm just going to give you 5 examples. Vaccinations, vaccines, chemistry. Climate change solutions, like electric vehicles, chemistry. Renewable and non-renewable energy, solar power, oil, gas, chemistry. A car is a driving chemistry experiment. Let me get 2 more and you're out of here. I'll be real quick. Technology, I'll just put tech and medicine. Get those and we'll call it a day. Once you have those written, you may leave. Bring a calculator tomorrow. We get into some numbers, all right? Don't forget that you have a vocabulary quiz on Wednesday. You may access your terms under the Unit 1 section of this class. I'll see you guys tomorrow.